This slide, in this lecture, we'll discuss mostly questions that are simple in nature. They're basically kinematics. Okay, where force is equals to mass into acceleration, and after you find out the acceleration, you have to deal with kinematics. So in today's lecture, we'll solve a lot of questions from kinematics. So let's start with the first question. So on this slide, we'll discuss a relatively simple question. Look at this. In this question, what is being said is that there is a cylindrical surface. The cylinder is hollow inside. Okay, that means a particle can move inside the cylinder of the inside the walls of the cylinder. Okay, now a particle out here on the wall of the cylinder is moving with velocity v naught, that is making an angle alpha with the horizontal. Okay, the cylinder has a radius r. If I look from the top view of the cylinder, that means if I look out from here, okay, I'll see the cylinder somewhat like this. The particle is moving with velocity v along the cylinder wall. Sorry, it has to be tangent. Okay, the particle is moving with velocity v along the cylinder. Okay, or along this plane, along the plane of the cylinder, or along the plane of the cylinder out here. The question is saying find the force with which the particle acts on the cylinder wall if the initial moment of the time of its velocity v naught and forms an angle alpha with the horizontal. That means if the particle is rotating around here, okay, what is the force that is keeping the particle on the circular orbit? The centripetal force. And who is giving the centripetal force? The normal reaction force. And we have to find out the value of that normal reaction force. Okay, also called the centripetal force. Acha, we know something. Centripetal force is equals to mass into centripetal acceleration. So normal reaction force is equals to mass into centripetal acceleration. What is the centripetal acceleration out here? V square by r, where r is the radius of the circular orbit. Now this v out here, okay, only the horizontal component would act in the formula for v square by r, no? Only the velocity which has this component, what is uh, in the plane of this circle. Okay, if I cut this cylinder, the component of the velocity along that cut circle, okay, will play a part on the centripetal acceleration. So out here v will be nothing but v naught cos theta, v naught cos alpha, not theta, sorry, v naught cos alpha. So out here v naught cos alpha whole square. So normal reaction force is equals to mass into v naught square cos square alpha by r. Okay, so that is the value of normal reaction force. Achha. In this question, a particle is there, okay, and a force is acting on a particle. A force is acting on a particle, okay, and the particle is accelerating. Okay, okay. Now the x displacement of the particle is given as a function of time, where x is equals to a sine omega t, and the y displacement of the particle is also given as a function of time. Y is equals to, sorry, f time or function of time, or b cos omega t. Okay, so out here the question is asking find the force acting on the particle. So total force or magnitude of total force, not magnitude, let's say total force vector, we'll find the magnitude at the last. Okay, is equals to force in x component I plus force in y component j. Okay, if you just fx square plus fy square is equals to total force, magnitude of total force under root. But let's find out the total force in x component and total force in y component. Force in x component is equals to mass into acceleration in x component. Okay, out here mass, acceleration, the displacement is given, so velocity in x component is equals to dx by dt. Okay, or a omega cos omega t. Okay, acceleration is equals to rate of change of velocity, or acceleration in x component is equals to rate of change of velocity in x component, dvx by dt is equals to a omega square or minus a omega square sine omega t. Okay, similarly dy by dt or velocity in y component is equals to dy by dt or is equals to minus b omega sine omega t sine omega t. Similarly acceleration in y component is equals to dvy by dt is equals to minus b omega square cos omega t. Okay, okay, plus mass into acceleration in y component j I. Acceleration in x component is equals to minus a omega square sine omega t, and acceleration in y component is equals to minus b omega square cos omega t. Okay, so the total force acting on the body is equals to m minus ma. Just write down the total force. Okay, you understood what I'm trying to do out here? Minus ma omega square sine omega ti minus mb omega square cos omega t j. Now the magnitude of force is nothing but I component plus j component square is equals to ma omega square sine omega t whole square, just minus will get translated to plus, minus mb omega square cos omega t whole square under root. Okay, if you solve this it is nothing but, or force is equals to, let's take uh m a acha m omega square constant, m omega square constant into under root of sine square or a square sine square omega t plus b square cos square omega t. So this is the final value of force, but this is the final magnitude of force that is acting on the particle. Now see, a sine omega t is nothing but x and b cos omega t is nothing but y. So the magnitude of force can be written as m omega square under root of x square. Why? Because a sine omega t is nothing but x plus y square. Okay, one more thing that I have to tell you. Okay, whenever x and y displacement are given as sine function, okay, sine and cos, most of the time, okay, 90% of the time or 95% of the time in your syllabus it will be a circular motion. Okay, this motion most probably represents a circular motion. Understood? So whenever sine and cos are given as a parameters of time in displacement, mostly it is a circular motion. Okay, in this question what the question is trying to say is, this is the axis, a body is thrown with velocity v naught in a projectile motion. Okay, let's say angle alpha. Okay, the angle alpha is not given, but let us assume angle alpha. Okay, the part A of the question is asking find the change in momentum for the first t second. That means what is changing momentum? Final momentum minus initial momentum, and momentum is a vector quantity. And what is the formula for momentum? Momentum is equals to mass into velocity. So out here mass of the body remains constant. Okay, only the velocity will change. So let's see, it has a y component of v naught sine alpha and x component of v naught cos alpha, v naught cos alpha. Now final momentum, x component of final momentum would not change. Why? Because in projectile motion there is no acceleration in x component, so x component of final momentum remains same. So P final is equals to V naught cos alpha, where y component of final momentum after time t. See, after time t, we simply have to apply the formula V is equals to U plus AT. Okay, our velocity at time t is required. U is nothing but V naught sin alpha. A is nothing but G or minus G. Why? While doing any vector calculations, always assign the coordinate system. Okay, and T. So V is equals to V naught sin alpha minus GT. So out here V naught sin alpha minus GT. Okay. Similarly, initial momentum of x component. See, initial x component of velocity is nothing but V naught cos theta. X component is nothing but V naught cos alpha, and y component is equals to how much? Initial y component of velocity is nothing but V naught sin alpha. V naught sin alpha. Since the mass remains constant, so momentum, the components of momentum will be m. So out here delta p is equals to dot change in momentum vector is equals to final momentum minus initial momentum 0. Okay, and final momentum of y component minus initial momentum of y component is equals to minus gt. Momentum is a vector quantity, it is j. Why? Because this minus gt came from y component. See, this minus this is nothing but minus gt for the first t time of motion. Now the question is asking, find the modulus of momentum, okay, delta p during the total time of motion. So out here the modulus, the velocity reached out here. So when the velocity reached out here, what would be the velocity at the end of trajectory? V naught, and this angle would be alpha. Okay, because the projectile is symmetric in midway. Okay, so the x component of velocity does not change, or x component of momentum will never change. So delta px will always be equals to 0. We have to find out delta py. Okay, so final momentum, part B of the question, change in momentum over the entire period. Okay, final momentum minus initial momentum. What is final momentum? Minus mv naught sine alpha. Why minus? Because v naught sine alpha is pointed towards downward direction. Is pointed towards downward direction. Minus of mv naught, mv naught sine alpha. Okay, this minus came from the formula. This minus, final minus initial. This minus is minus, and this minus is nothing but the direction of the final momentum minus. Okay, initial momentum is positive out here. See, v naught sine theta is positive out here. So out here total change in final momentum would be minus 2 mv naught sine alpha in j component. Okay, is there any momentum in x component? Is there any change in momentum in x component? No. So total change or modulus or magnitude of change in momentum in in y component would be, or in any component would be 2 mv naught sine alpha. Okay, you can apply the formula also, to come out to be same. This entire square plus 0 square under root is nothing but this only. Okay, only the minus sign gets disappeared. Achha, a little bit of error out here. Out here gt is to be multiplied by m. Okay, because the entire velocity will be multiplied, no, m gt. Out here minus m gt. You can simply apply the dimensional analysis. No, g into t has a dimension of velocity. Okay, this question is nothing but a question of kinematics under the guise of dynamics. A force is acting on a particle of constant mass. The mass of the particle is not changing, and force is given by at t minus t. That means as the time increases, the value of force increases. Part A of the question is asking, Find the momentum of the particle when the action of the force is discontinued. That means when is force is equals to 0? Force is equals to 0. You have to find out when is force is equals to 0. Or at into tau minus t is equals to 0. This equation has two solutions. T is equals to 0 and t is equals to tau. See, at t is equals to 0, the force is just starting to get applied. That means at time is equals to 0, I'm just starting the force. So we have to take time t is equals to tau, because at t is equals to tau, force is equals to 0. That means at that time the force is going to stop. Okay, fair and fine. Now how do I find out the momentum of the particle? Okay, can I say change in velocity, or a is equals to dv by dt? Okay, or a dt is equals to dv. Okay, we also know force is equals to mass into acceleration. So can I say, using these two equation, okay, a t into t minus t and mass into acceleration, can I say acceleration is equals to at into tau minus t divided by m? Okay, this entire m divided by this one. Or at into tau minus t by m dt is equals to dv. Okay, if we integrate this one, this is nothing but at tau by m minus at square by m dt is equals to dv. Okay, or a tau by m t square by 2 minus a t cube by 3 m plus some constant is equals to v. Now I have to apply boundary conditions. Okay, the first boundary condition is at t is equals to 0, v is equals to 0. How do I know? See, a stationary particle, that means the particle was stationary at t is equals to 0. That means v is equals to 0 out there. V is equals to 0. Okay, some of you are confused, sir, why are you not applying direct integral? See, direct integral and indirect integral are same thing. Okay, in direct integral you apply the limits, in indirect integral you apply a constant and apply some boundary condition to find out the value of that constant. It's basically more, see, if you are very familiar with the concept, okay, if you are steady first and have a firm grasp over concept, you can go definite integral, that's much quicker. But to understand that, in some problems, see, these are simple problems, okay, but in some problems it's recommended to apply indirect integral and solve with boundary conditions. Okay, we'll get much clarity with the concepts. So if I apply t is equals to 0 and v is equals to 0, okay, I get the value of constant is equals to 0. Or v is equals to a tau t square by 2m minus a t cube by 3m. Now the question is asking, find out the momentum of the particle when the action of the force is discontinued. Okay, at t is equals to 0, what is the momentum of the particle? 0. Why? Because v is equals to 0 and momentum is equals to mass into velocity. So p initial is equals to 0. Now what is p final? For p final you have to find out v final. What is v final? You have to substitute this t by tau. Okay, because you are finding out at tau when the force stops. So v final is equals to a tau cube by 2m minus a tau cube by 3m. So it's basically 1 by 2 minus 1 by 3, which is nothing but 1 by 6, or a tau cube by 6m, that is v final. So what is p final? Momentum final is equals to mass into velocity. So a tau cube by 6m, you just cancel out the masses. So final momentum is equals to this one, and change in momentum will be this value only. Why? Because initial momentum is equals to 0. Now the second part of the question is asking, find the distance covered by the particle when the force acted, okay, from initial to time t is equals to t naught. So for finding out the distance, we need to remember the formula for velocity. Okay, so just remember the formula for velocity. Now in part B, we have to find out the displacement of the particle from t is equals to 0 to t is equals to tau. We simply know that v dot dt is equals to dx. Okay, so simply we integrate velocity a tau t square by 2m minus a t cube by 3m into dt is equals to dx, or a tau t cube by 6m minus a t to the power 4 by 12m is equals to x plus constant is equals to x. And some of you might have doubt that why aren't you adding the constant this side. It doesn't matter. As soon as we apply boundary condition, the value of constant will give you the direction also. Okay, so out here at t is equals to 0, x is equals to 0, because you are starting from covering from starting point, no? So at t is equals to 0, at t is equals to 0, x is equals to 0. If we apply the boundary condition in this formula, what happens? The value of constants becomes 0. So x is equals to a t cube by 6m minus a t to the power 4 by 12m. Okay, and we need to find out the displacement at time t is equals to tau. So displacement or x final is equals to a tau to the power 4 by 6m minus a tau to the power 4 by 12m, or x final is equals to a tau to the power 4 by m 1 by 6 minus 1 by 12. Okay, or x final is equals to a tau to the power 4 m. 12 minus 6 is nothing but 6 divided by 72. Or final displacement is equals to a tau to the power 4 by 12m. Okay, now in this question there is a block of mass constant m. Okay, and a force is applied on this block. The force is given by f naught sine omega t. Okay, that means this is a variable force, and the block would be accelerating. Achha, can you all tell me what is the acceleration of the block? Acceleration of the block is nothing but force divided by mass, or f naught sine omega t divided by m. Why? Because force is equals to mass into acceleration. Now the question is asking, find the distance covered by the particle as a function of t. Okay, so in order to find out the distance, first you need to find out the velocity. So we do know that a dt is equals to dv. Okay, or if we integrate, what is the value of acceleration? F naught sine omega t. A dt is nothing but acceleration into dt. Most of you all know that by now. Divided by m into dt is equals to dv. Achha, if we integrate it, it becomes nothing but minus f naught by m omega cos omega t. Okay, plus some constant is equals to v. See, integration of this one with respect to dt is nothing but minus f naught by m omega cos omega t. Okay, now in order to find out the value of constant, you have to apply boundary condition. What is the boundary condition? See, at the moment t is equals to 0, the particle of mass m starts moving. That means at the moment t is equals to 0, the velocity e or v is also equals to 0. So at t is equals to 0, v is equals to 0. So the first boundary condition we have is at t is equals to 0, v is also equals to 0. Now when you apply t is equals to 0 and v is equals to 0 out here, what do you get? See, at t is equals to 0, cos 0, cos 0 is nothing but 1, okay, and v is equals to 0. So we are left with minus f naught by omega m omega is equals to, plus constant is equals to 0, or constant is equals to f naught by m omega. See, if you apply t is equals to 0 and v is equals to 0 in this equation, you get the value of constant as f naught by m omega. So you have to write down the entire equation of velocity. So minus f naught by m omega cos omega t plus f naught by m omega is equals to velocity. Okay, we got the equation of velocity. But now you need to find out the displacement or distance covered by the particle as a function of t. So let's try to find out the displacement. Okay, then we'll start with the distance. So we know that v dt is equals to dx. Okay, or if I apply, what is the value of v? The value of v is nothing but minus f naught by m omega cos omega t plus f naught by m omega into dt is equals to dx. Now when I integrate this one, or when I integrate this function, what do I get? I get nothing but minus f naught by m omega square sine omega t. Okay, I'm integrating this part and I have to integrate this part also, plus f naught t by m omega plus some constant is equals to x. Okay, now we need to find out the value of this constant. And how do I find out the value of constant? By putting boundary condition. So boundary condition out here is at t is equals to 0, x is equals to 0. Okay, that means what? At time t is equals to 0, the body starts moving. Okay, find the distance covered. So if you're finding out the distance covered, regardless of the value, it is better to calculate the distance from the origin, no? So if I want to find out the distance covered, okay, just put x equals to 0. Okay, if you put x is equals to any other value, we'll get the value. Then again, distance is equals to final position minus initial position. So it doesn't matter. So for simplification, if you are asked about distance at t is equals to 0, x is equals to 0. Okay, so out here, if you put t is equals to 0 and x is equals to 0 in this entire equation, this entire terms become 0, this entire terms become 0, and this is x is already equals to 0. So the value of constant is equals to 0 out here. Our equation of displacement becomes minus f naught by m omega square sine omega t plus f naught t by m omega equals to x. Okay, Asha, can I rewrite this equation? Find the distance covered. This is the distance covered at time t. Okay, or x is equals to, I'm taking minus, not minus, let me take f naught by m omega square, or f naught by m omega common. Okay, what do I get? Minus sine omega t by omega plus t. Can I bring this t this side and this sine omega t to the right hand side? So x is equals to f naught by m omega t minus sine omega t by omega. Okay, this is the value. So let me erase this one. Now the question is asking us to plot this graph. Okay, plot the graph of x versus t, and that is a purely a concept of mathematics. See, x t. Okay, so suppose even I don't know how this graph looks like, but I do know there is a parameter of t out here. See, sine omega t is nothing but a repetitive function. Okay, the maximum value of 1 and a minimum value of -1. But out here, there is a t out here. So that is tangential function. That means there would be a line. That means addition of this line somewhat, this line plus this line. the ultimate graph or the resultant graph would look like addition of this graph plus this graph. So can I say the resultant graph will look like somewhat this? Okay, so the resultant graph of this x versus t will somewhat look like this. In this question, what the question is saying is that there is a particle out here of mass m. Okay, the force being applied is F naught cos omega t. Okay, how long will it be moving until it stops for the first time? So when does a particle stop? The particle stop when v is equals to 0. Okay, if force is given, that means the value of acceleration is given, where acceleration is equals to force divided by mass, F naught cos omega t divided by mass of the object. Okay, and how do I find velocity from acceleration? A dt is equals to dv. What is the value of a? F naught cos omega t by m into dt is equals to dv. If I solve out this integral, it would be F naught by m omega into sine omega t plus some constant is equals to v. Similarly, the boundary condition out here at t is equals to 0, v is equals to 0. Why? The particle starts moving, v is equals to 0. If you put t is equals to 0 out here and v is equals to 0 out here, okay, the value of constant becomes 0. Okay, so the equation of velocity becomes v is equals to f naught by m omega sine omega t. Okay, so the first part of the question is how long will it be moving until it stops for the first time? See, it stops when the velocity becomes 0, no? So velocity becomes 0 when sine omega t becomes 0. So when does sine omega t become 0? Sine omega t becomes 0 when omega t is equals to either 0 or pi. Pi means 180 degree, okay, or 360 degree, 2 pi, okay, or 3 pi. That means natural number multiples of pi. At natural number multiples of pi, the value of sine omega t becomes 0. Okay, so it stops for the first time when omega t is equals to pi. That means sine omega t becomes 0. So when omega t is equals to pi, out here it started and it stops for the first time out here. So out here omega t is equals to pi, or t is equals to pi by omega. The second part of the question is what distance will it travel during that time? That means what is the distance covered? So this is the equation of velocity. Okay, if I integrate this one with respect to dt, I get displacement, or v dt is equals to dx, or f naught by m omega sine omega t into dt is equals to dx, or out here what do I get? uh, Minus f naught by m omega square cos omega t, okay, plus some constant is equals to x. Now if you need to find out the distance traveled, you have to start at x equals to 0. So the boundary condition out here would be at t is equals to 0, x is equals to 0. That means at t is equals to 0, the particle started at origin. Okay, so if you put x is equals to 0 out here and t is equals to 0 out here, you get the value of constant as f naught by m omega square plus f naught by m omega square. See, put the value of t is equals to 0 and x equals to 0 out here. So the value of x, okay, is nothing but f naught by m omega square minus f naught by m omega square, f naught by m omega square cos omega t is equals to x. Okay, I just wrote this first and this one second. I just interchange them. Okay. Now, what is distance will it travel during the time? During that time. Okay, what is the time? The time was nothing but pi by omega. So out here time is nothing but pi by omega. Pi by omega. So omega into pi by omega is nothing but pi. And what is the value of cos pi? The value of cos pi is nothing but -1. So this entire term would be -1. So out here we get f naught by m omega square, minus and minus becomes plus, f naught by m omega square is equals to x, which is equals to 2 f naught by m omega square. Okay. Now the third part of the question. What is the maximum value of velocity over this distance? Okay. The maximum value of velocity is nothing but this one. Okay. Velocity is given by this equation. And what is the maximum value of this equation? When sine omega t is equals to 1. Okay. Why? Because the maximum value of sine omega t or maximum value of sine function is nothing but 1. Okay. So V max or maximum value of velocity is nothing but f naught by m omega. Okay. This is the maximum value of velocity provided in this distance, or maximum value of velocity in its entire motion. Achha, in this question, in river, there is a boat. The boat is driven by engine. So the boat was coming from here. And as soon as it reached out here, the engine stopped. And the moment at which the engine stopped, the boat had a velocity v0. Okay. So this boat had a velocity v0. The mass of the boat was m. So the boat should be moving forward. But what happens? Drag forces of the water acts on the boat. Drag forces means nothing but friction force of fluid. Drag is nothing but a fancy term for fluid friction. Okay, either air friction or liquid friction. So drag friction of water acts on the fluid. And the formula for drag is minus r into v, where v is the velocity, r is the constant out here. So if there is drag force out here, there will be acceleration or deceleration. Deceleration means acceleration is opposite to the velocity vector. And what is the value of acceleration? Minus rv by m. Why? Because force minus rv is equals to mass into acceleration. Now the first question is, how long does the motorboat move with the shutdown engine? That means how long will the motorboat move? Okay, the motorboat will move till the velocity becomes 0. So till v is equals to 0. Now my next question is, when is the velocity 0? Okay, so can I rewrite the equation, or can I draw the equation a into dt, or not a into dt, dv by dt is equals to acceleration. And what is the value of acceleration? Dv by dt is equals to minus rv by m, where r and m are constant, only v is variable out here. Okay, so can we integrate this v with dv? Of course. Or dv by v is equals to minus r by m dt. I just took this v down here and dt up here. Okay, now see, if I integrate this, it will have ln v is equals to minus rt by m plus some constant. Okay, now in order to find out the value of constant, we need to put up a boundary condition. So the first boundary condition is at t is equals to 0. So at t is equals to 0, what happened? The velocity of the boat was how much? v0. So at t is equals to 0, v is equals to v0. So if we apply this boundary condition out here, what do we get? ln v0 is equals to, or constant, the value, see, if we put ln v0 is equals to minus r into 0 by m. So constant is nothing but ln v0. ln v0. Just put t is equals to 0 and v is equals to v0 in this equation. We get the value of constant is equals to ln v0. So our main equation of velocity becomes ln v is equals to minus rt by m plus ln v naught. So if we bring this ln v minus ln v naught is equals to minus RT by M. Okay, or out here this equation becomes nothing but ln v by v naught is equals to minus RT by M. Okay, or e to the power, or v by v naught is equals to e to the power minus RT by M. Okay, or v is equals to v naught e to the power minus RT by M can be written as 1 by e to the power RT by M. Okay, because e to the power minus 1 is nothing but 1 by e. So this one. Okay, now see in this equation, when does the velocity become zero? See, v naught is a constant, so the velocity becomes zero when this denominator becomes infinity. And when does the denominator become infinity? At t is equals to infinity. Okay, so this e to the power infinity is nothing but infinity, and any constant by infinity is nothing but zero. So the motorboat will go on for eternity. So at t is equals to infinity, velocity becomes zero. Understood? Now the second part of the question. Second part of the question is find the velocity equation. See, out here the velocity equation is in terms of time, no? So the second part of the equation, find the velocity of the motorboat as a function of displacement. So you have to find out velocity as a function of displacement. Velocity as a function of displacement. Okay, we can simply use the same relation. Okay, force is equals to mass into acceleration, or d dv by dx. What is it? This is nothing but acceleration, is equals to, what is the value of acceleration? Minus rv by m, minus rv by m, minus rv by m, where v and v will get cancelled. So out here dv is equals to minus r by m dx. Okay, so if I integrate this one, it will be something like v is equals to minus rx by m plus some constant. Okay, if we put some boundary condition out here, what is the boundary condition? At x is equals to 0, that means at t is equals to 0, I am considering my boat at origin. Okay, v is equals to v naught, v is equals to v naught. So out here constant, if I apply x is equals to 0 and v is equals to v naught out here, the value of constant is nothing but v naught. Okay, so our main equation of velocity function to x becomes v is equals to minus rx by m plus v naught. So when does the boat stop? The boat stops when the velocity becomes 0. So we have to find out, see, we find out the velocity as a function of x. So v as a function of x will be this value. I have to find out as well as the total distance covered by till the complete stop. That means when will the boat completely stop? When v is equals to 0. So if we solve this, v naught is equals to rx by m, or x is equals to mv naught by r. Mv naught by r is equals to x. Or if we solve this equation, x is equals to mv naught by r, mv naught by r. Now some of you might have confusion. Okay, Acha, let's solve the problem, then I'll tell the confusion later. The confusion I have here is, if the time taken is infinity, that means the boat is going on moving forever, no? How did it stop? Okay, that I'll explain at the end of the question. The mean velocity of the motorboat over the time interval beginning with t is equals to 0, during which the velocity decreases n times. Now the third part of the question is the mean velocity of the motorboat over time interval with which the during which the velocity decreases n times. That means find the average velocity, okay, from starting time till the time when velocity becomes n times of initial velocity, or till the final velocity becomes this value. Okay, so when the final velocity becomes this value, what is the distance traveled? If I simply put final velocity out here, I'll get the distance. So x is equals to, for x we use equation number 1. And why am I finding out x? Because mean velocity or average velocity, what is the formula for average velocity? Total displacement by total time. Total displacement by total time. Total time. So out here, what is the final velocity? V naught by n is equals to minus Rx by m plus V naught. Okay, but to find out the value of x, or out here, V naught by n minus V naught is equals to minus Rx by m. Okay, or if you multiply both hand side by minus, V naught into 1 minus 1 by n is equals to Rx by m. Okay, I've skipped a step out here. So I have taken V naught common. If I take V naught common out here, it would be 1 by n minus 1. Okay, and if I multiply 1 by n minus 1, it would be 1 minus 1 by n. So I multiplied minus 1 out here and minus 1 out here. Minus 1 out here became plus out here. Understood? Or out here, x is equals to how much? V naught m by r, 1 minus 1 by n, 1 minus 1 by n. So out here, total displacement is equals to V naught m by r, 1 minus 1 by n, 1 minus 1 by n. Now what is the total time? Total time you have to find out by this equation. Okay, you have to put V is equals to how much? V is equals to V naught by n. So if you put V is equals to V naught by n, V naught by n divided by V naught is equals to e to the power minus RT by n. If we solve this, 1 by n is equals to e to the power minus RT by n. Taking log both sides, okay, ln 1 by n is equals to minus RT by m. ln 1 by n is nothing but ln 1 by m is nothing but n to the power minus 1, n to the power minus 1. If I take log, this minus 1 goes outside, and this minus becomes plus. Okay, or ln n is equals to RT by m, or t is equals to m by r ln n. Okay, now if I substitute the value of t out here, total time, that is the time when velocity becomes v naught by n, is equals to m by r ln n. Okay, this m and this r cancelled by this m and this r. So out here, average velocity, this average velocity is equals to v naught 1 minus 1 by n divided by ln n. Okay, this is the average velocity till when velocity becomes n times the initial velocity. Okay, now the doubt I have here is, if the time taken for velocity to become 0 is equals to infinity, how come it's stopping at x is equals to mv by r? Okay, although I got this by, I got x is equals to mv by r from this equation, time is equals to infinity from this equation, but how is this happening? If it is never stopping, then how come we have a displacement at 0 or at v is equals to 0? See, it works with the principle of how exponential graph works. Okay, if this is v, okay, and this is t, the graph of this graph, okay, v versus t, would look something like this. Okay, so up till here, majority of the velocity has been decreased. Now from here, this graph tends to infinity. That means this graph will meet the x-axis or t-axis at infinity. Okay, but can I say the entire distance or the integration from this part, what is v dt? Vt is nothing but the displacement. Okay, majority of the displacement happened out here, and from this part to infinity, okay, displacement one happened only, but displacement will be negligible compared to this much value, or the area under this minute curve or minute area out here would be much negligible compared to this larger area. Okay,
So in practical engineering, when most of the cases when exponential cases comes up, not only these cases, what we do is we take 99% of the value. So 99% of, although v becomes 0 at t is equals to infinity, but v becomes 0.01 times v at certain value or at certain time, and that time is much smaller than infinity. See, if you put v is equals to 0.01 v naught, okay, time will come out to be how much? E to the power minus rt by m is equals to 1. So ln 1. So time will be very less compared to infinity. Understood what is happening out here? And at 0.01 velocity v naught, okay, the amount of displacement traveled or amount of displacement or area under this curve will be very less compared to this larger area. Understood why? Even though the time is at infinity, that means the body will never stop. We got a displacement because we are calculating the majority of the displacement out here, not ignoring the amount of displacement caused by the negligible amount of area down here. Understood? So what this question is saying is that there is a plank. Okay, suppose there is a plank out here. Now inside this plank there is a bullet traveling. Bullet is traveling with velocity v naught. Okay, let me draw the bullet out here. And the bullet's not stopped. Out here, the velocity of the bullet is nothing but v. Okay, so let me draw the bullet out here. Initial position of the bullet just before entering the plank is v naught, and out here the velocity reduced to v. Okay, inside the bullet there is a force acting on the bullet, and that force is nothing but friction force due to this plank. Okay, now it is given that the resistance force or the friction force by the plank on the bullet is proportional to the square of velocity. That means friction force is proportional to the, or force is proportional to the square of velocity. Okay, so force is equals to some constant into velocity square. Okay, fair and fine. Now this force will cause an acceleration. The acceleration will be opposite to the direction of velocity, and we know that force is equals to mass into acceleration. So acceleration out here would be equals to force, which is kv square, divided by mass. Acceleration is equals to force by mass. So this bullet has an acceleration of kv square by m, and it deaccelerated to a velocity of v. The question is asking find the time of motion of the bullet in the plane. That means till what time this velocity v naught has reached to this value. Okay, so we simply know that dv by dt is equals to acceleration, or dv by dt. What is the value of acceleration? Kv square by m. Okay, or let's send dv by v square is equals to k by m dt. Just send this v square down here, dt right here. Okay, if you integrate this, it is nothing but v to the power minus 1 by minus 1. Okay, integration of this one is nothing but this one, plus some constant is equals to k by m t. It doesn't matter you introduce the constant out here and or constant out here. As soon as you the boundary condition, the value of constant would come accordingly. Okay, or minus 1 by v plus constant is equals to kt by m. Okay, this value minus 1 by v. Okay. Now out here we have to put the boundary condition at t is equals to 0. At t is equals to 0, velocity is equals to v naught, v is equals to v naught. Okay, so let's put, see, let's put v naught out here and t is equals to 0 out here. Okay, so we get the value of constant is equals to 1 by v naught. When you put v naught out here and t is equals to 0 out here, the value of constant is equals to 1 by v naught. So our equation of velocity becomes nothing but minus 1 by v plus 1 by v naught is equals to kt by m, or 1 by v naught minus 1 by v is equals to kt by m, or t is equals to how much? T is equals to m by k. I just send the k by m to the left hand side. T is equals to m by k 1 by v minus 1 by v. So this is the answer. Okay, but I have a problem out here. The problem is the value of m, or the variable of m or k, is not present in the question. Okay, there is no variable of m or k. Okay, these are the constant I introduced. What is the variable introduced in the question? Gone through a plank of thickness h. That means this thickness is h, or this length is h, or the distance it traveled in time t is equals to h. So somehow you have to convert m by k in terms of h. V naught m and m by k in terms of v naught and h. So out here, what is the relation between acceleration and displacement? V dv by ds, v dv by dx is equals to how much? V dv by dx is nothing but acceleration. Okay, and what is the value of acceleration? Kv square by m. Okay, v square v got cancelled, or dv by v is equals to k by m, dv by v is equals to k by m dx. If I integrate this, ln v is equals to k by m x plus constant. Okay, now if you are consider our origin to be out here, okay, so at x is equals to 0, v is equals to v naught. Okay, so if we put the value of x is equals to 0, v is equals to v naught in this equation, we get the value of constant as ln v naught. So our main equation comes out to be ln v is equals to k by mx plus ln v naught, or if I send the v naught to the left hand side, ln v minus ln v naught is equals to kx by m. Now I have second boundary condition. Second boundary condition means that at velocity is equals to v, x is equals to h. Boundary condition 2. At velocity is equals to v given in the question, x is equals to h, distance traveled is equals to h. Okay, so you put v is equals to v out here, okay, and x is equals to h out here, we get the equation of, acha, let me transfer this equation, let me write this equation neatly. Okay, ln v by v naught is equals to kx by m. So out here, if I write ln v by v naught is equals to kh by m. Okay, and what do we need to substitute? We need to substitute the variable m by k out here. So let me transfer it out here, or how do I transfer m by k? M by kh, m by kh is equals to 1 by ln v by v naught. Okay, this is nothing but v at time t, velocity is equals to v. Okay, so out here the value of m by k, the value of m by k, or m by k, is nothing but h by, if I send the h to the right hand side, it will get cancelled from here. I just send the h from here to out here. And if I substitute this m by k out here, I'll get time t is equals to, or 1 by v naught minus 1 by v into m by k. What is the value of m by k? H by how much? Ln v by v naught. Ln v by v naught. So this is the value of time that is taken for the bullet to travel distance h inside the plank. Okay, so out here time taken is equals to this value. In this question, what happens that there is an inclined plane. Okay, the angle of the inclined plane is alpha. Now a block is kept out here, and this is considered to be origin. Out here, this direction is x, and perpendicular to x is y. Now, as the block travels downward, okay, suppose it travel distance x downward, the coefficient of friction is dependent upon this x. That means as I increase, as the block goes downward, okay, the surface becomes more and more rough somehow in the question, and the friction force increases and increases. Okay, now the question is asking, find the distance covered by the bar till it stops. That means initially what? Initially x is 0, so the surface is frictionless. So gravity will pull it downward very fast. And after some time, what happens? After some x, what happens? The friction force is so large that it overcomes the value of gravity force. Okay, and it tries to pull the force, or it tries to pull the acceleration in that side while the velocity is still in that side. Then after a certain times, velocity becomes so large that it finally stops. Okay, now see, if I draw the free body diagram of the body M, okay, out here what is the force? Mg sine alpha. Out here what is the force? Mu mg cos alpha. And what is the value of mu? The value of mu is nothing but ax. Okay, so can I say, and this is the direction of acceleration, can I say mg sine alpha minus ax nothing but mu, mg cos alpha is equals to mass into acceleration. Out here m and m would get cut, so out here m and m is getting cut. What is the value of a? The value of acceleration is nothing but v dv by dx. Okay, acceleration can be written by v dv by dx. What is my purpose for writing this one? So that I find out the distance when velocity becomes 0. V dv by dx. So if I rewrite this equation, sine alpha, okay, or out here I erase the g sine alpha minus ax g cos alpha into dx is equals to v dv. If I integrate this one, this would come as gx sine alpha minus ax square by 2, acha, ag x square by 2, ag x square by 2 cos alpha, okay, is equals to v square by 2. Okay, so out here, sorry, I forgot to put out the boundary condition plus some constant. Whenever I integrate, a constant is introduced. So out here, boundary condition at x is equals to 0, v is equals to 0. That means out here initial velocity is equals to 0. How do I know? A small bar starts sliding. Start sliding means initial velocity is equals to 0. So if I put x is equals to 0 out here, x is equals to 0 out here, x is equals to 0 out here, and v is equals to 0 out here, the value of constant out here becomes nothing but 0. So the equation will remain as it is. Okay, now the first part of the question is saying find the distance covered by the bar till it stops. That means again this velocity will become 0. Okay, the velocity started at v is equals to 0. When the bar will stop, the velocity will become equals to 0. So can I say from this equation, okay, this is the equation of velocity, this is the equation of velocity, the bar will stop when the velocity becomes 0. Or when does the velocity become 0? When g sine alpha, if velocity becomes 0, I'm taking this entire term to the right hand side. is equals to g a x square by 2 cos alpha. G and g would get cancelled, x and x square would get cancelled. Sin alpha by cos alpha is nothing but tan alpha. Okay, so let me make it neat and clean. Out here, tan alpha, out here g will get erased, x square will get erased, cos alpha will get erased. So x is equals to how much? X is equals to 2 by a tan alpha. Okay, so out here distance when the body will stop is equals to 2 by a tan alpha, or x is equals to 2 by a tan alpha. Now the second part of the question. The second part of the question is find the distance, find its maximum velocity over this distance. That means what? Initially the velocity is equals to 0. Okay, somewhere midpoint the velocity will become maximum. Then again the friction force is so much that the acceleration will reverse its direction, and the velocity is starting decreasing and starting to decrease and again became 0 out here. So the midpoint between here and here, there is somewhere a point where velocity is maximum. Okay, the question is asking find out that maximum velocity. Okay, so can I say out here gravity force is pulling, gravity force is dominant at the initial point. Okay, and after a certain point when the direction of acceleration reverses, okay, out there friction force is dominating. Okay, so it started from 0, it is increasing the velocity. Okay, it will only start decreasing the velocity when the acceleration direction of acceleration is reversed. That means if I draw a v versus x graph, I don't know how the graph looks like. Okay, but just apply common sense. It is starting from here. So starting from 0 velocity and it is increasing. Okay, it is increasing with the help of what? Why does velocity increase? Due to force. So mg sin alpha is dominant out here. Okay, after a certain time, what happens? The direction of acceleration reverses. Why does the direction of acceleration reverse? Because now friction force become dominant. So if friction force become dominant, that means velocity will try to decrease. Why? Because velocity and acceleration are in the opposite direction, and again it will come out here. So somewhere in the midpoint there is a maximum velocity, Vmax. All I am trying to say is that at this maximum velocity, the total acceleration will be equals to 0. That means before changing the direction of acceleration, somehow between here, between positive acceleration, between when this force is dominant, and between this negative acceleration, between when this force is dominant, there existed 0 acceleration. So add Vmax, acceleration is equals to 0. Okay, so out here, if acceleration is equals to 0, this entire term, this is nothing but free body equation, no, free body diagram equation. So g sin alpha minus ax cos alpha is equals to 0. This is the force equation. Or g sin alpha minus ax cos alpha, or ax g cos alpha, sorry, ax g cos alpha is equals to 0. G gets cancelled, so out here tan alpha by a is equals to x. X is equals to tan alpha by a. Okay, okay. Now question is asking what is the value of that maximum velocity. So this is the equation for velocity, no? This equation I got is the equation of velocity versus x as a function of x. So if I input the value of x out here, okay, if I input this value of x out here, I get the maximum value of velocity. Now we get the maximum value of velocity at x equals to tan alpha by a. If I input tan alpha by a in this equation, I get nothing but g tan alpha by a, or g tan alpha by a into sin alpha minus a g by 2. Okay, what is x square? Tan square alpha by a square into cos alpha is equals to v max or maximum velocity square by 2. If I solve this one, g by a tan alpha sin alpha minus g by 2a. See, out here tan square alpha into cos alpha is nothing but tan alpha and sin alpha. Tan square alpha is sin square alpha by cos square alpha. Cos alpha and cos square alpha gets cut. So it's nothing but sin square alpha by cos alpha. And sin alpha by cos alpha is tan alpha, and we're left with one more sin alpha. So this entire value, tan square alpha into cos alpha, is nothing but tan alpha into sin alpha. So into tan alpha into sin alpha is equals to maximum velocity square by 2. If I take g by a tan alpha, g by a c, g by a tan alpha sin alpha common out here, 1 minus 1 by 2 is nothing but 1 by 2, v max square by 2. So 1 minus half is nothing but half, 1 minus half. Okay, so out here 1 by 2, this 2 and this 2 would get cut. So v max is equals to under root of g by a tan alpha into sin alpha is equals to v max is equals to maximum velocity. Okay,